This presentation is an overview of the monohybrid crossing assignment for VI 112 students at Mount Hood Community College. So the first thing you'd want to do is go to Table 1 of the monohybrid crossing data sheet and determine what your phenotypic and genotypic profiles are. So you'll notice on the table you have the traits on the left-hand side here, and then you have your phenotype possibilities here and your genotype. So for the phenotype, the first term is considered the dominant trait, and the second term would be the recessive trait. And then when you determine by looking at the pictures in the assignment which trait you have, then you would determine your genotype. If you are a recessive trait, it's pretty easy because you would have, for example, here you would have the two lowercase letters. If you have the dominant trait, though, you wouldn't know if you were homozygous dominant or heterozygous. So if you look at this statement up here, you'll notice that the assumption you're making is that you are heterozygous. So if you had free earlobes, for example, you'd have a big L, little l, as your genotype. So your job is just to go through these and determine what your phenotype and genotype are, and then circle your genotype. You will need to find a partner and to do the same thing because we're going to do some Punnett squares here in a second. And look at that. Once you determine your genotypes for you and your partner, then you're going to go to this table and write those genotype alleles down, and we're going to go through the process of determining potential offspring. If you and your partner were to have kids, what would be the potential offspring for some different traits? What would be their genotype? So what you are going to do then is you are going to show your genotype, your partner's genotype. Now these genotypes, and you'll see I have a big K and a little k. I'm going to make the assumption that you have the dominant trait, both you and your partner have the dominant trait for nose, and so K is the allele letter that they use for that. And I'm going to make the assumption that you're heterozygous. What you need to just remember is that those two letters are homologous pairs. So one's on the paternal chromosome, one's on the maternal chromosome. And in meiosis 1, they separate. And so you'll notice that we will separate those two letters into the different gametes here. And you'll have a big K and a little k in two gametes. So one set of gametes could be the egg, the other set of gametes could be the sperm. So you write those down, and then a Punnett square, let me get my little pen. So this Punnett square here is a theoretical way of determining if you knew the genotype of the parents, which is the big K, little k up here in the egg and the sperm. You could make a prediction of the potential outcome of offspring and what chance they have of having a Roman nose or a straight nose. So what you do is basically put one set of alleles on the top of this square and one set of alleles on the left-hand side of this square, and you're basically going to cross them. So for example, here we would cross these two big K's, and you notice that we get two big K's in that box. And then we're going to cross the big K with this little k, and we will get this combination here. So you do that for the 4 boxes, and then from that information you can determine what the phenotypic ratio is. And remember, the phenotype is the expression. It's what's evident. It's what you see and what appears. So that's going to be the nose shape in this case. And then the genotypic ratio is going to be the alleles that you have. So let me erase this. So after you determine this, then you look at the offspring and you determine what's your phenotypic ratio. So what we can see is that we have 3 boxes here that contain the dominant trait. So being that this is completely Mendelian, the dominant trait rules. And so you'll notice that you have 3 boxes that have the dominant trait. So those individuals would potentially have a Roman nose. So what you'd write here is you have 3, or you could use 75% potential that the offspring of these 2 parents would have a Roman nose, and there would be a 1 out of 4 or a 25% chance that they'd have a straight nose. Then in the phenotypic ratio, what you would see is that we have 1 that is 2 big Ks, which means it's homozygous dominant. You could also say that that's 25% homozygous dominant. And then you notice we have 2 that are heterozygous, and we have 1 that is homozygous recessive. So from that information, then you could say it's a 1 to 2 to 1 ratio of the genotype. And so that's basically what you would do there's 3 other ones that you would do for that information. So next we go to the monohybrid problems, which you'll see for number 1. Number 1 is so easy that students sometimes make it hard. Basically what you're doing is you're starting with this genotype, RR, and determining, okay, if you started with that genotype in stage G1, and you went through the whole process of meiosis 1, meiosis 2, everything, and after cytokinesis 2, what would be the 4 gametes? Because if you remember at the end of meiosis, we always end up with 4 gametes. What would be the 4 gametes? So just to make a long story short, basically both of these are homologous pairs, so they're going to make sister chromatids. So you're going to end up with a tetrad of 2 big R's, 2 little r's. And then you will go through meiosis and separate those into the 4 gametes. And then all you have to do is list what the 4 gametes would be, right? And what their alleles would be. And so each gamete would have 1 letter from this combination. Okay, so I'm just going to go over one of the problems. There's several problems, kind of like story problems that you'll have to do. And let me just go over number 6, which is on the same page down at the bottom for the monohybrid problems. So looking at these, what I like to do first of all is just determine what I know. So you'll notice right here, I basically, oops, I can't make an arrow very well with my mouse. But anyway, right here, you'll see I listed what I know. So if you read the question, says if a plant is homozygous for white color, is crossed with a plant homozygous for yellow, white is dominant. So I wrote a big W for white and a little w, and remember on your paper, because I can't make one here, but on your paper you would put a little line over the W for the recessive trait. That shows it's lowercase, and so a little w for yellow. You always, the recessive trait always follows the lettering of the dominant trait. So if you have a W for white, you're going to have a little w for yellow. So you don't use a Y, you use a little w. So we know which one's dominant, which one's recessive, and then it says if a plant is homozygous for white, so you'll see here it's homozygous for white, and it's homozygous for yellow, then what would be the phenotypic and genotypic ratios? So basically, this is the way I would set it up. As you say, you've got big W crossed, put an X with a little w. And then, just like we did before with you and your partner's genotype, we're going to separate those homologous pairs into gametes. So on the left-hand side, you'd have your gametes for the parents. On the top, you'd have the gametes for the other parent. And then here is going to be your offspring, which is referred to as the F1 generation. and you just cross them. And so you'll notice that for our offspring, we basically got all the same. Um, so our phenotypic ratio, because white is dominant, is we're going to have 4 white to 0 yellow. And then for genotypic ratios, we're going to have basically 4 heterozygous to 0 homozygous dominant to 0 homozygous recessive. So that's the way you'd set it up. So again, what I would recommend is just reading the problem and determining what the dominant traits are, and giving them letters. Now you can basically give them any letter you want to. Most times they give them the first letter of the dominant trait, but you don't have to. You can make up your own letters as long as you give the key as to what's dominant, what's recessive. And then you just go through the Punnett squares. So for monohybrid, you always use 4 squares, and you just determine what the phenotypic and genotypic ratios are. And that's basically it. All right.